and welcome back. So in this video we're going to be using SOHCAHTOA to find missing angles of right angle triangles. So the objective here is to calculate missing angles in right angle triangles using SOHCAHTOA. So here's an example. We need to find x. So the first thing we're going to do, as we usually do in a SOHCAHTOA question, is we label the sides. So I'm going to label the opposite, the hypotenuse and the adjacent. So the opposite in this case is the 2, because the 2 is the one that's opposite the angle, so that's O. The hypotenuse in this case is 3, because that's the longest side and the side that's opposite the right angle, so that's H. And then the other one is A, so that's the side that's adjacent to the angle, so that's that. So I'm going to continue to do as I normally would with these questions and cross out the side that's not really involved. So in this case, that's the A. We don't need the A and we don't have the A. So I'm left with O and H. So I'm going to continue as I usually would with SOHCAHTOA questions by writing out the acronym SOHCAHTOA. And I'm looking for the one that involves O and H. So O and H is SOH, so I have sine. So SOH stands for sine theta equals opposite over hypotenuse. So now if I sub in the values, I end up with sine theta. In this case, theta is the angle and the angle is x, so I'm going to call it x instead. Sine x equals opposite over hypotenuse, so that's 2 over 3. So now this one's a bit different. To work out x, what I do is I do the inverse of sine. All functions have an inverse, so the opposite of multiplying is dividing, the opposite of adding is subtracting, the opposite of taking sine of something is taking the inverse sine of something. So the way we write it is we write x equals sine to the power of -1 of 2 over 3. So on your calculator, if you type shift and then sine, you should have sine to the -1. So if you do that, you should end up with 41.8 degrees, and that is the answer. So here's another example. So again, what I'm going to do this time is start off by labelling the sides. So I have my side that's opposite the angle, so that's O. I have my adjacent side, which is A, and I have my hypotenuse, which is the side that's opposite the right angle and also the longest side, so that's H. So this time I'm going to cross out O because O is not really involved. We don't need O and we don't want to know O. So I'm left with A and H. So if I write SOHCAHTOA, the one involving A and H is Ka. So in this case we have cos. So cos theta is adjacent over hypotenuse. So subbing in the values, I have cos of x is adjacent, which is 1 over 5. The inverse of cos is cos to the -1. So we have x equals cos to the power of -1 of 1 over 5. So if I type this into my calculator, I get 78.5. Here's another example. So again, I'm going to label the sides. So 5 is the opposite, 12 is the adjacent, and the hypotenuse is the side that's opposite the right angle. I'm going to cross out H because that's not really involved, and I'm left with O and A. So I have SOHCAHTOA. The one involving O and A is TOA, so I have tan theta is opposite over adjacent, that's the formula. So we have tan of x, which is the angle in this case, is opposite, so 5 over adjacent, which is 12. So the inverse of tan is tan to the -1, so it's tan to the -1 of 5 over 12. And if I type this into my calculator, I end up with 22.6 degrees. So here are some quick fire practice questions on this topic. Pause the video, have a go at these, and I'll reveal the answers in a moment. Okay, so well done if you managed to have a go at those. Here are the answers, and that's everything for this video. So thank you so much for watching, and I'll see you again in another video. Bye!